Is it recording? All right, class. Back to the drawing board. Success Chemistry class 101. We are looking at reaction stoichiometry. Reaction stoichiometry. And we have a question on the board already. We have a question on the board already. We are given pH3. We're given this chemical reaction, pH3 plus 4Cl2 to give 3HCl plus PCl5. Given that P is 30.95 grams, Cl is 35.45 grams, and H is 1.008 grams. Please, help me with my book there. I dropped it there. We're asked to find, Clara, what did they ask us to find in this question? We're asked to find the mass of what? Mass of chlorine gas that will be used to produce 1,800 grams of PCl5. Class, when they give you a chemical reaction like this, there are a lot of people involved in the chemical reaction. But you don't have any business with all of them. Just pick the people you have a business with. We have to find the mass of chlorine gas. So we have a business with chlorine that will produce what? That will be used to produce 1,800 grams of PCl. So class, our business is between chlorine and PCl5. Our business is between chlorine and what? PCl5. Our business is between chlorine and PCl5. We have to find the mass of chlorine gas that will be used to produce 1,800 grams of PCl5. Class, question we have to ask ourselves. Anytime they ask you a question in an exam or in a classwork, first ask yourself, from the balanced equation, what mass of chlorine gas gave what mass of PCl5? From the balanced, before you now go to the main question. Class, you say from the balanced equation, what is the mass of chlorine gas in the balanced equation? We have 4 times 2, we have 8 atoms of chlorine. 8 atoms of what? And each atom of chlorine from the question is 35.45. So the mass of chlorine gas in this equation is 8 times 35.4. Do you agree, class? Because according to the question, each chlorine is 35.45. And from the balanced equation, we have 8 chlorine, 4 times 2, 8. So 8 times 35.45. Can someone do that for me? What's the answer? 2 what? 283.6 grams. So from the balanced equation, we have 283.6 grams of chlorine gave what mass of PCl5? 283.6 grams of chlorine gave what mass of PCl5? Let's find the mass of PCl5 from the balanced equation. Class, from the balanced equation, first of all, phosphorus is at 30.95, right? That's 30.95 plus chlorine is 5 chlorines. Plus 5 times 35 point. Because we have chlorine is 35.5, right? Multiply by 5, because we have 5 chlorines. Plus 5 times 35.4 to get the total mass of PCl5. Who has already done the math for us? What will it be? 208.2 grams. So class, on the balanced equation, 283.6 grams of chlorine gave 208.2 grams of PCl. Please, if I'm too fast, always let me know. Now, you have gotten this on the balanced equation. Now, go to the question. What does the question want? Calculate the mass of chlorine. What mass of chlorine you don't know, call it what? Any place you don't know, put it as an unknown letter X or A or B or Y. What mass of chlorine will now produce 1,800 grams of this same PCl5? How many grams of chlorine will produce 1,800 grams of this same PCl5? What do we do next? We cross multiply. Cross multiplying means that x times 208.2 is 208.2x equals 283.6 multiplied by 1008. 283.6 multiplied by 1800. 283.6 multiplied by 1800. How do we do it again? In case if I'm too fast, x times 208.2 is 208.2. 283.6 multiplied by 1800. So we have 208.2x. Who has done this math for us? 510,480. Please, as I'm doing this, someone should be keeping an eye on that video. If there's anything that's changed, let me know. Let me not be deceiving myself here. It's still video, Nabi. If there's maybe something battery low or something, just let me know so I will know that. So now make x subject of the, divide both sides by 208.2. So 510,480 divided by 208.2. 2,000. 0.7777787. Class, this is the mass of chlorine that will produce 1,800 grams of PCl5. Class, what kind of stoichiometry we call this? Mass to mass. Because there's mass on this side, there's also mass on this. Class, they could have said what mole of chlorine. They could have said what is the number of mole of chlorine that will produce 1,800 grams of PCl5. That one is what? Mole to mass. Mole to, because this guy is still mass, but this side is now moles. So they can say, so if it was what moles of chlorine will produce 1,800 grams of PCl5, if it was say what number of moles of chlorine, if the question said what number of moles of chlorine will produce 1,800 grams of PCl5, that is mole to mass. Mole to what? Now, it means that from the balance equation, what we would have gotten here is mole, not mass, right? Because this side must be mole, this side must be mass. Mole to, because if they say what number of mole of chlorine will produce 1,800 grams of PCl5. What number of mole of chlorine will produce 1,800 grams of PCl5? That's mole to mass. But this one did not say mole, it said what? Mass. They say what mass of chlorine will produce 1,800 grams of PCl5? Good. Now, the reaction of nitroglycerine, under question. The reaction of nitroglycerine, the reaction of nitroglycerine the reaction of what? Nitroglycerine, you now write C3H5, 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 open bracket NO33, open bracket NO33, C3H5, open bracket NO3, NO3, then you close the bracket 3, NO3, then you close the bracket 3. In case you're lost of what I'm saying, I'll write on the board soon. Let me clean this quickly. Class, I'll come again. The reaction of nitroglycerine, C3H5, open bracket NO33. This is what I mean. C3H5, open bracket NO33. A powerful explosive reaction is as follows. The reaction of C3H5NO33, a powerful explosive reaction, is as follows. They want to give us the reaction. They want to give us the reaction. So we have C3H5NO33 to give 6N2 plus O2 plus 12CO2 plus 10H2O. C3H5NO33 to give 6N2 plus O2 plus 12CO2 plus 10H2O. Class, I haven't written a balanced equation. The equation balanced is balanced. A. Question A from this reaction. A. How many moles of nitrogen are produced from 6 moles of C3H5 NO3 3. If you are here and you're very good in video editing, see me after the class. You'll be paid for the service. I will not have time to be. I need someone that will help me edit the videos. Success Chem 101 class. Because you'll be chapter by chapter. 1 Chem 101. Measurement system. You edit it, make it look presentable. You're very good in that. You are skilled in that. Can edit a video, CapCut, all those things. See me after the class. See me after the. How many moles of nitrogen are produced from 6 moles of C3H5NO33? B. How many grams of water how many grams of water will be produced from 200 grams of an explosive? From 200 grams of an explosive that contains only 80%. That contains what? Only 80% of the nitroglycerine. Of the nitroglycerine. We have C as 12, H as 1, N as 14, O as 16. C as 12, H as 1, N as 14, O as what? 16. Class, the question we have is on the board. How many grams of water we produce from 200 grams of an explosive that contains only 80% of the nitrogen glycerine. A, how many moles of nitrogen are produced from 6 moles of C3H5NO33? Class, this question A, what kind of stoichiometry is it mass to mass, mole to mass, mole to mole, mass to volume? God bless you, mole to mole. Because how many moles of nitrogen we produce from 6 moles? So it's mole to... So that's the first thing you should recognize. The question will be mole to volume. I'll give you different questions, don't worry. Now, class. How many moles of nitrogen are produced from 6 moles of C3H5NO33? Now listen up. How many moles of nitrogen are produced from 6 moles of C3H5NO33? Now, from the balanced equation, from the balanced what? As usually you start from the balanced. Class, first of all, the first thing you do is pick, this is the reaction. Who and who is involved in this reaction? We're not using everybody in the reaction. How many moles of nitrogen? So nitrogen is involved. And from 6 moles of this, right? This is the nitroglycerine. This is the what? The nitroglycerine. So how many moles of nitrogen are produced from 6 moles of this? From the balanced equation, 4 moles of this, 4 moles of the nitroglycerine, right? Gave 6 moles of nitrogen. 4 moles of the nitroglycerine gave 6 moles of what? Nitrogen. Four moles of nitroglycerine gave 6 moles of nitrogen. So how many moles of nitrogen will be produced from 6 moles of nitroglycerine? We don't know. We'll call it what? Is the nitrogen side that is unknown, right? So we'll call it X. So 4 moles of nitroglycerine gives 6 moles of nitrogen. 6 moles of nitrogen will give how many of nitrogen? We don't know. Call it. We then cross 4 times X. 4X equal to 6 times 6. 30. Can we divide both sides by 4? The 6 divided by 4. 9 moles of nitro. So the first answer to the first part of the question is 9 moles of nitrogen. It is 9 moles of nitrogen that will be formed from 6 moles of nitroglycerine. The second part of the question now said, how many grams of water, how many grams of what? Will be produced from 200 grams of an explosive that contains 80% of nitroglycerine. The explosive contains 80% of nitroglycerine. How many grams of water? Class, how many grams of water? An explosive contains 80% of nitroglycerine. So the mass of nitroglycerine in the compound will be 80% of 200. Do you agree? Let me explain myself again. An explosive contains, the mass of an explosive is 200 grams. Out of that 200 grams, 80% of it is nitro. So how do we get the mass of nitroglycerine out of the 200? It's 80% of 200. Do you agree? If an explosive is 200 grams, but in that explosive, only 80% is nitro. Only 80% is nitro. But the total explosive is 200 grams. How do we get the mass of nitroglycerine inside the 200 grams? 80 over 100 of 200. We give it the mass of nitroglycerine, which we are concerned. 80% of 200 will give you 160. So the mass of nitroglycerine is 160 grams in the explosive. The mass of nitroglycerine in the explosive is 160 grams. The mass of nitroglycerine in the explosive is 160 grams. $160 grams. But is that the question? No. How many grams of water will be produced then? How many grams of water will be? So it means that if 160 grams of nitroglycerine is available, what mass of water is formed? So this stoichiometry is between nitroglycerine and what? Water. This stoichiometry is between what? Nitroglycerine and water. This stoichiometry is between nitroglycerine And what kind of stoichiometry is it? It's mass to mass, right? Because how many grams of water will be produced from 200 grams is mass to mass. Grams means mass. 200 grams of explosive, mass. But after the 200 grams, why are we not using the 200 grams of explosive? Because not all the explosive is nitroglycerine. So I've collected the part of the explosive that is nitroglycerine is 160, right? By 80%. Now, class, from the balanced equation, what mass of nitroglycerin gave what mass of water? From the balanced, what mass of nitroglycerin gave what mass of water? From the balanced, we're now going to find, after getting that, we'll now say, okay, what of 160 grams will give what? X, we don't. Are you following? Your brain must be involved in these learnings. Those that are sleeping, I believe you are following us in the other world, right? In the spirit realm, you are with us. Follow me. We need to get the mass of nitroglycerin. You must be very careful here. What is a complex compound? If you look at it, some people, if you just try to find the mass of this compound, they will not get it. Or they will take time to get it. How do you do something like this? What's to go about this 4? Get everything here, multiply by 4. Get everything here, multiply by. Or 4, it affects everybody here, right? So, see, they even generous enough to give us the masses of each component of the reaction. C is 12. We have 3 carbons here. 12 times 3. Remember I said, forget about this 4 first, right? So someone should not say, out of this 4, leave the 4 out. Let's just get everything here. 12 times 3, 30. Plus hydrogen is 1 times 5. 5. 36 plus 5. N is what there? 14. But we have 3N. 14 times 3, 42. 14 times 3. Because this 3 is affects everybody in the brackets, right? Oxygen is 3. 3 times 3, 9. So we have 9 oxygens. 16 times 9. 16 times 9 is what? 16 times 9 is 144. 144? Now everything multiplied by. If there was a way you used to do this kind of thing in secondary school, and that's how you know it, continue your own way. There are many ways to kill a bird. 36 plus 5. 41 plus 42. 83. 83 plus 144. Eh? 2, 2. 4 times 2, 2, 7. 9. So class, from the balanced equation, we have 908 grams of nitroglycerin. Gave what mass of water? Class, I know that H2 is 18. So if we have 10 of H2O, 10 times 18, 180. Class, H2O is 18 because 2, hydrogen is 2, oxygen is 16. 2 plus 16. So we have 10 H2O, that is 18 times 10, 180. So class, from the balanced equation, 908 grams of nitroglycerin gave 180 grams of H2. How many grams of nitroglycerin is now available? 160 grams of nitroglycerin will now give what? We don't know, we'll call it what? X. 160 grams of nitroglycerin will produce what mass of water? We don't know, we'll call it X. What do we do next class? We cross. So 908 times X will give you 908 equals 160 times 180. So that's 908X. What's 160 times 180? You see? 28,008. Now divide both sides by 90. 31.71 gram of water. If you want to put it to 2 decimal place, 31.72. Right? That's the mass of water produced from 200 grams of an explosive that contains only 80% nitroglycerin. I'll give you a moment to write and we'll move forward. Class, let us be fast. Another question. Calculate the mass of iron that will be produced from 10 grams. Calculate the mass of iron that will be produced from 10 grams of iron 3 oxide from the reaction shown below. I'll show you the reaction below. Calculate the mass of iron that will be produced from 10 grams of iron 3 oxide from the reaction shown below. Calculate the mass of iron that will be produced from 10 grams of iron 3 oxide from the reaction shown below. From the reaction shown below. Calculate the mass of iron that will be produced from 10 grams of iron 3 oxide from the reaction shown below. From the reaction shown below. The reaction shown below, class, is Fe2O3 plus 3CO to give 2Fe plus 3CO2. From the reaction shown below. Fe2O3 plus 3CO to give 2Fe plus 3CO2. CO. CO is a compound on its right. Hope you know. Carbon monoxide. There's one between carbon monoxide and carbon dioxide. B part of the question. The question now continues. B. What volume of carbon monoxide at STP will be needed to convert 200 grams of iron 3 oxide to iron. What volume of carbon monoxide at STP will be needed to convert 200 grams of iron 3 oxide to iron? And we are given Fe equals 55.9. We are given C equals to 12.01. We are given O equals to 16. And we are given 1 mole of gas at STP equals to 22.4 liters of gas equals to 22.4 liters of, I'll give you a moment to write why we, okay, there's even a C part of the question. There's a C part of the, what volume of CO will be needed at STP, will be needed at STP if 200 grams of iron 3 oxide was actually 90% pure. Was actually 90% pure.